Hey everyone, my name is Harris Masick, founder and CEO at Cyber Infrastructure Technologies. We are a spin-out venture from the University of Utah focused on cryptography and communications. Next slide, please. Security is one of the major concerns of modern communication systems. And with cyber attacks growing in size and sophistication, there exists an ongoing need for ultra-secure communication technologies to uphold secure, accurate, and efficient data transfer. Next slide. So far, we have been operating as an advanced cybersecurity laboratory, translating the latest advances in signal processing and communications technology into solutions for enterprise and government. We've been committed to the development of scalable data assurance technologies for the ever-expanding Internet of Things, and we focus specifically on data acquisition. Next slide. For traction, we are a proud recipient of a U.S. Air Force STTR for dynamic systems mapping and analysis. We're also part of two accelerators, the University of Utah Company Launch Program and the newly formed Quantum Startup Foundry at the University of Maryland. We've also partnered with the NATO SPS Quantum 5 team and Flux Research Group at the University of Utah to develop solutions for securing data and transmission. Next slide. So what is the technology? Well, data transmission is no stranger to packet loss. But what can you do when the missing information is vital? The technology we're developing with the Air Force tests the continuity of data packets and predicts, based on what came before and after a signal, what information is missing or garbled. The tool could be used for debugging, data analysis, or error detection for all types of transmissions, including facsimiles and analog to digital conversions. But our current focus has been on applications related to data acquisition systems. Next slide. Glancing at the data acquisition systems market, there's a few key takeaways. One, the market is quite small at $1.8 billion. Two, the market is primarily driven by R&D in the aerospace and defense industry. And finally, this makes it a fitting niche for our work, enabling us to concentrate our marketing efforts at the DoD. Next slide. For intellectual property, we have an exclusive patent license with the Army Research Laboratory for a non-line-of-sight optical communication scheme, and 6 non-exclusive research patent licenses with NASA. The top 3 patents plus our own relate to optical communications, while the bottom 3 relate to nonlinear signal processing. We had plans to further develop the quantum technologies and tackle challenges of distributing entanglement, but have shifted our focus back to traditional communications after some discussions at the Innovaria Aspire Summit with the Air Force Research Laboratory. Next slide. We currently have 4 services: modeling and simulation of communication networks, including QKD, integration and testing of QKD with existing telecom infrastructure, network organization solutions, and network management. These all kind of fit under the umbrella of research and development at this time, but we could offer it to enterprise as well. Next slide. For SWOT analysis, we have our strengths with an access to network test beds thanks to our academic partners, optical communication, signal processing IP, and telecom know-how. We have an existing contract with the Air Force Research Laboratory through AFWERX. The weaknesses, there's difficulty in finding good talent, and we lack a personal laboratory, which results in anywhere from 30 to 60% of our R&D budgets being allocated to research institutions. For opportunities, there's plenty of federal R&D funding for communications technologies and the upcoming Quantum Investor Summit at the University of Maryland. For threats, we have Amatech, Teledyne, and Signalscape. The first 2 are the larger players in this space, and they're mostly focused on hardware. Signalscape bears the most resemblance to us at this time, but they've struggled with scalability. Next slide. Today, we're looking for corporate partnerships in the form of R&D collaboration or letters of support, an MOU from interested DoD stakeholders, and we're also looking to start conversation with interested investors. We're currently raising $750,000 with resource matching being provided by the University of Utah and Air Force Research Laboratory. Next slide. Taking a look at our roadmap, you can see the company was founded a little over a year ago. We are currently focused on securing 1 to 3 R&D grants or contracts and plan to pitch at the Quantum Investor Summit come October. We've also recently attended the Innovaria Aspire Summit and will be establishing a collaborative research and development agreement with the Air Force Research Laboratory. For 2022, we'll begin development of scalable signal analysis technologies with the AFRL and hope to get a simpler product released by the fall. And finally, in 2023, we'll begin testing and evaluation of our prototype with the AFRL. If all goes well, the work will translate to an OTA contract to help resolve warfighter needs. Next slide. For our team, you can see myself as founder and CEO, Dr. Miralim Mehic as our telecom research scientist, and Dr. Miroslav Voznak, our signal processing lead. Next slide. Thank you. I'm open for any questions.
Okay, open up the floor. Nilesh, I think you're first up.
Yeah, let me introduce myself. I'm Nilesh Trivedi from the Bay Area. We are sort of a stage agnostic and a sector agnostic fund, mostly funded by close to about 400 investors across the board, founders, VCs. They all invested in us. We are sort of a community-based fund. My question, Harris, is what is your business model? You basically want to license the IP, or you want to, some of this is all protocol based, as far as I know, routing companies, for example. So I'm kind of curious, how will you actually get your technology into your customers' hands?
You're right, and that's why we've actually been functioning as a sort of cybersecurity laboratory since our inception in 2020. But that's why we're planning, especially for 2022, to integrate the technology we've already developed into a sort of scalable middleware solution. Especially with IoT, having a middleware solution integrated with sensors, you can start standardizing the data. And data heterogeneity is a huge problem with IoT. So having a sort of scalable data acquisition system, it would be a really good way to scale the business model. I hope I answered your question, but I could dive into more details if needed.
Okay, sure, thanks.
Go ahead, John.
Yeah, John Reifenberg. I am Director of Technology at Sierra Nevada Corporation. We are the largest privately held aerospace and defense company in the United States. My question is, and forgive me, I'm not that fluent in this type of technology, but my question is, can you provide a tangible example of how a defense customer might use the product that you're offering or the services you're offering?
Yeah, so at the Innovar Aspire Summit, we actually had the Air Force Research Laboratory lead for our challenge problem. And they basically described the issue with they're collecting radio signals, and they want to ensure that these radio signals are accurate before acting on that information. So what we do is essentially just scour the signal, look for any missing or garbled information, and correct that, or at the very least detect it.
Okay, thank you.
Go ahead, Cassandra.
Yeah, thank you for the presentation and all the information. Cassandra Crothers from Upheaval Investments. I was curious, what actually are you building at the core? I heard you mention a prototype, so I'm wondering if there's hardware innovation involved, or if it's off the shelf, if it's heavily software, and or if it's heavily services.
I think I did mention, we put the optical communications hardware stuff on the side now, especially because we had this Innovar Aspire Summit recently, and the Air Force specifically wants to partner on developing a software solution. So this is what I'm talking about with middleware. It's essentially software interfacing with the hardware components. So we have the sensors that collect the signals, and then our software will look at those signals and correct any errors, or at the very least detect those errors before then it goes to the operator. They can act on that information.
Got it, thank you.
Go ahead, Lydia.
Was curious to hear, hi, I'm Lydia from Next47. Curious to hear more about your kind of the timeline of development, kind of the roadmap of the product. Kind of when do you expect to have like product in the hands of customers and actually get revenue, so like significant revenue?
So the core technology has already been developed and evaluated by the University of Maryland as well. So we have a support letter documenting that. The main issue is now just integration with sort of more accessible solutions. And that's why I really focus on middleware, because I think that's where the main focus will be. And I'm hoping to get the product out by fall of 2022. But the CRADA is going to last for probably 3 years. So I'm not entirely sure what kind of developments we're expecting throughout the whole 3 years. But I hope that we can get some major product development done in the first.